The craziest project man has ever dreamed of has been floating over our heads for more than 20 years. The International Space Station.
There's nothing else like it in human history.
The size of a football field, the ISS is the biggest man-made object ever created. It travels above us at a speed of 28,000 kilometers an hour.
It's a unique construction, a permanent fixture in space.
How were engineers and astronauts able to put together this 400-ton machine?
It's the most complex engineering building that we have ever constructed as humankind.
The ISS is the only weightless space station in existence and an incredible tool at the service of humanity.
It's a huge success, and down to the collaboration of many different countries.
It's thanks to the ISS that everyone's focus is now on Mars.
It's the place that allows us to imagine the future.
It's a tool that allows us to fly further, higher, and faster.
The space station is really our first step on our further journey into space.
Space is an extreme and hostile place. Mankind has had to demonstrate incredible ingenuity and rise to huge technological challenges to allow astronauts to live there, almost as if they're living on Earth.
Inside, it's small, like a telephone booth, but it's pretty cozy.
How does the space station work? How do they repair it? How does one breathe inside it? Where does it get its energy from?
It's filled with bags of rubbish. I need to crouch right down because there's not much room. I'll try and show you.
We are going to take a trip backstage on board the International Space Station on a guided tour in the company of those who know it best, the astronauts.
If I had the chance to go tomorrow, I would go back tomorrow. It's such an incredible place.
Mankind has always dreamed of traveling into space, leaving the Earth, and discovering new horizons. This crazy quest has gradually become a reality. But the dream hasn't stopped there, and to go even further, they built a structure over our heads, 400 kilometers above the planet, the International Space Station. A steel monster some 108 meters long and 73 meters wide. It required the expertise of American, Russian, European, Canadian, and Japanese space agencies to put this incredible scientific laboratory into orbit. Like an enormous construction set, each piece was designed and constructed on Earth before being transported into space. It took 10 years to assemble in a challenge that went way beyond international borders. For almost 20 years now, 200 men and women from different countries have dedicated themselves in turn to live and work on board the International Space Station.
Of course, the station has become our baby. It's our favorite toy, and we never get bored of it. It's our home, our place of work.
Reaching the space station is no simple feat. It involves a long voyage on Russian Soyuz spacecraft. After a 48-hour flight, the Soyuz is within 400 meters of the ISS.
The first thing that you see is a bright dot, like a star, that is showing up somewhere on the display. As you get closer and closer, you see a little bit this dot growing. Then you see the wings, the big solar wings of the space station.
Like explorers discovering a new world, each time they approach the station, even the most experienced astronauts can but marvel at the spectacle.
It's really huge. You've seen it so often in photos, images, or video, but you can't believe that human beings were capable of constructing this huge station in orbit in space.
Then out my window, I could see solar arrays and thermal radiators and pieces of the station that kind of extend out into that corridor that we're traveling in. And they just get closer and closer and closer and fill the view of your window. You actually feel like you're being engulfed by the space station as you're coming in on a Soyuz.
I've been to the station 3 times, and each time my feelings were the same. Admiration. Admiration for the size of it. It's truly gigantic.
It looks wrong. I mean, it looks to your eye, there's something alien about everything you see. You will see any beam or post or module extremely well lit on one side, over bright, kind of, harsh lighting. And then right as you get roll around to the side that is not directly facing the sun, it is black.
Range is 3. The roll has stabilized. There is no roll now. There is no roll deviation. We're approaching really nicely. Contact confirmed. And probe retraction confirmed.
Docking confirmed. A textbook arrival for the brand new Soyuz MSO-1 spacecraft. Docking confirmed at 11:06 p.m. Central Time.
You're going from this incredibly cramped Soyuz through a hatch system, which is actually even more cramped. Once you open that, you still have the 2 hatches, the ISS hatch and the Soyuz hatch, to get past. So you're actually moving through an even tighter little space, and sort of being pulled in by your crewmates. You're coming through a birthing canal and being aided by the doctors on the other side to pull you across and into the main volume of the space station.
And the hatch now opening.
And when you leave the little ship and enter the huge station, you're overcome with emotion. You discover this huge space. You recognize some faces. It's really moving. Of course, it's overwhelming.
The total volume of the ISS is comparable to that of a 5-room house, and it was designed to be home to 7 astronauts. Each one stays there for an average of 6 months. From their very first moments on board, and despite their years of training, new arrivals are often disconcerted because they have to learn to live in zero gravity, where there is no up or down.
You're in 3 dimensions, and you're using a module that is up there, on the left, on the right, below, in front, behind. It's a bit complicated to get your bearings in the beginning.
Your brain sometimes processes the image completely different because the fluid in your inner ear is sending a completely different message to your brain. You're looking down the tunnel, and it's almost like you're looking up a building. You know what I mean?
I made a right turn into the service module, and then suddenly I stopped because suddenly I couldn't recognize where I was. And I thought to myself, I can't believe I'm already lost on board the International Space Station, especially because I've spent hundreds of hours training in a model of it here on the ground. But luckily, one of the more experienced astronauts could see that I looked a little bit confused, and he told me, it's because you're standing on the ceiling. As soon as I flipped over and got my feet back on the floor again, it was as if everything fell into place and I could suddenly recognize where I was.
The astronauts find their way around thanks to a marking system that shows them up and down. The absence of gravity also gives them a 360-degree working environment.
Of course, most of these modules you'll see, they have 4 sides, and they're put together. That way we could sort of work on a flat plane, either a wall
a floor, another wall, or the ceiling. But, you know, again, all you have to do is turn yourself and your reference changes.
This almost complete lack of gravity presents its own problems for the human body.
We are not used to function in microgravity, so we have too much blood pressure in our head. The blood shift is happening, so that's why you see astronauts, certainly in the beginning when they fly to space, that they have kind of a swollen head with red puffy face.
The astronauts' faces look a little puffy because their blood flows differently. The blood doesn't flow as well to the lower part of the body and accumulates in the chest and head. The veins around the neck and face swell up. So naturally, the change of blood flow presents some problems.
So you actually feel that inside your head. You feel this increase in intracranial pressure, and it causes some stuffiness in the nose as well, sometimes a bit of a dull headache as well. But, and that can actually last for a few weeks as your body adapts and adjusts to microgravity.
But the ISS is much more than a simple home in orbit around the Earth. Above all, it's a top-flight science laboratory in permanent residence in space. Over the past 2 decades, astronauts have carried out over 1,700 experiments there. Japan, the US, and Europe have each supplied a lab: Kibo, Destiny, and Columbus. The almost total lack of gravity and the almost total vacuum outside the station makes for an environment that is impossible to recreate on Earth. These two properties create ideal research conditions and the chance to use some unique chemical and physical processes.
This research can be absolutely fundamental, with essential questions involving the effects of gravity on metabolic modifications, on combustion, on alloys, on fluid mechanics, with issues we can't explore on Earth because we cannot remove the effects of gravity.
The research carried out in this permanent space lab covers multiple fields like biology, material science, observation of the Earth, and astronomy. The results of some experiments already carried out have allowed us to create revolutionary new alloys and new medical treatments. The ISS also means we have a permanent human presence in space and can thus prepare for future manned voyages to other planets.
Not only have certain experiments been useful for key research, but some will help us fly farther, higher, and faster.
The success of the veggie experiment, which involved growing lettuce in orbit, is considered a real advance in terms of long-term space missions. The system was designed to supply a permanent source of fresh food to the crew.
Cheers, 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 cheers.
On board the space station, they are also carrying out experiments in robotics. In a few years, remote-controlled robots could build other stations or even carry out experiments. This is another stepping stone towards Mars.
But the special thing about this joystick was that I could feel the forces that the robot was exerting. And that's sort of a first step towards developing what we call an exoskeleton arm, which is a robotic arm that you can wear yourself. And as you move your arm, the robot follows your arm movements, but at the same time, it sends back the forces, so you can actually feel and control the forces that the robot is exerting.
In the future, humans will also need to be capable of withstanding very long voyages. As such, the human body is also subjected to experiments on the ISS.
Tube's filling up quite nicely.
We're guinea pigs up there, so we're participating in experiments studying the effects on our bodies in that environment, the weightlessness, radiation, and any other aspects of that unique environment.
The last 10 years have shown that the vision of 75% of astronauts is altered by long stays in space. For a long time, it was believed that the rush of blood to the head was behind these sight issues. But recently, it has been established that the liquid surrounding the brain and the spinal cord can also play a role in these vision problems.
We're still not quite sure of the cause. There are some theories that it's intracranial pressure causing it. Maybe higher CO2 levels that we breathe in the atmosphere might contribute towards this as well. But what seems to be happening is a flattening of the retina. And that flattening of the retina is causing up to about a diopter shift in vision, so becoming nearsighted.
What this shows us is that in the end, human beings have an astonishing capacity to adapt. In a weightless environment, the astronauts' bodies lengthen and can grow between 2 to 7 centimeters in length.
And this is something I find that's remarkable about our human body, is how good it is at adapting to new environments. If we were going to live in space in microgravity permanently, then the human body is brilliant. It would be offloaded, the heart muscle would shrink, our bone density would reduce, our muscle mass would reduce, and we would very quickly become a very good being, a very good body for living in microgravity.
After 6 months in orbit, it's only when they return to Earth that the astronauts truly realize the importance of gravity's pull on their bodies.
It was really shocking. After my first flight, I felt just how heavy my arms were. Really, really heavy. I could also feel my guts. I really could. I don't know how to explain it to you, but I could feel the organs inside me. And I can tell you, they're really heavy.
The idea of establishing a manned space station in orbit around the Earth is not a new one. In the 1920s, the Russian Konstantin Tsiolkovsky, the undisputed grandfather of astronautics, imagined a space station where men could live. In 1971, the Russians sent the first space station into orbit, named Salyut-1. The Americans responded 2 years later with Skylab. Then, in the middle of the Cold War, in 1975, the Russians and Americans proved that space cooperation was possible with a joint Apollo-Soyuz mission.
After Apollo-Soyuz, there was a pause in the manned spaceflight programs in both the USSR and the USA.
In the mid-1980s, space cooperation was no longer. The Americans had the shuttle, and the Soviets were dominating manned spaceflight with the Mir station. The USA was planning to build its own station, but given the mammoth size of the task and the cost involved, the Europeans, Canadians, and Japanese came on board. With the collapse of the Soviet bloc, Russia was also invited to join the adventure, and the result was the ISS. Everyone involved committed to sharing their knowledge and supplying part of the station. The construction process was simple. 15 modules would be built on Earth and then assembled in space.
In fact, the space station is the biggest plug-and-play that has ever been made.
The scope of the project was immense.
Today, we still talk about the pyramids with admiration. And the ISS is the same. In the future, we'll talk about the ISS like we talk about the pyramids.
The space builders entered the frame in 1998, when the first American module was anchored to the first Russian one. Over the space of 2 years, more and more missions set off to build the station and prepare for the arrival of its first permanent residents. On November 2, 2000, cosmonaut Sergei Krikalev officially became the first resident of the International Space Station.
The first thing we had to do was to turn the lights on. We had to establish the link with Earth, and I had to find a cable hidden behind a panel. And then we could do the first report. Yes, the first thing we had to do was turn the lights on. After that, we plugged in the service module systems. We started the unit for creating air, for purifying the carbon dioxide, and ventilating with oxygen. They were critical moments. If we hadn't been able to get that going, we wouldn't have been able to stay on the station for long because the reserves in the Soyuz vessel were very low.
Building the station took 115 launches to bring the modules and teams into space. Canada provided a key element in the shape of a robotic arm. 17 meters long, it is used to move modules, supplies, material, and even astronauts. The fruit of international cooperation, the ISS gradually took shape in the sky.
We designed every mission so that if something didn't work, we would put it back into the shuttle and we'd bring it back home, but we never had to do that. Everything worked up there, and it was amazing.
Especially when you consider that many components of the space station never were tested together on the Earth and integrated only on paper.
Of course, it was all theoretical, and I was pretty surprised to see that we got it fully deployed. It's an absolutely extraordinary example of technological prowess.
The construction and operation of the International Space Station is the most expensive project ever undertaken by humankind, costing some $150 billion.
Firstly, it's not a huge amount of money, and what we're getting in return is a vast amount of scientific knowledge and understanding that is benefiting people back here on Earth. And if nothing else, it's an incredibly valuable insurance policy for the future.
From Earth, you can now clearly see this giant construction set that shines so brightly in the sky.
The reason it's so bright is because of the massive solar arrays. The surface area of those solar arrays provide such a great reflective surface for a viewer on the surface of the Earth. And it's through those solar arrays that we capture the sun's energy, produce electricity, and charge batteries that are then discharged when we're on the night side of the Earth.
When fully deployed, each panel is 73 meters long. They are permanently angled to face the sun, and each one is comprised of more than 32,000 solar panels to capture energy from the sun.
So the solar rays articulate, so as we orbit around the Earth at 4 degrees per minute, the solar rays articulate at 4 degrees per minute to continue to point to the sun. We also have, because of the orbit that we're in, we have a change in what we call the beta angle, and that means the solar rays have to articulate in this degree of freedom as well. And we have joints that do that, and the computers track the sun and then control the solar rays accordingly.
Together, the solar panels from the ISS could supply the electricity for around 40 houses. This unique energy source is of vital importance for the crew.
There would have to be a catastrophic accident for the station to end up without power. But even if that did happen one day, we have independent batteries. And we also have solar batteries on our Soyuz vessels. It's virtually impossible to imagine the station without electricity.
These are the crew quarters. There are 4 here. I'll show you what mine looks like inside. There's my name on it, and that's how I know it's mine. Inside, it's small, like a telephone booth. But it's pretty cozy. I have my computer for emailing my family and for calling them via Skype with a headset. I have another computer, an iPad, and the stuff I need for work. Here you just stick everything on the wall. That's how you do it in a weightless environment.
And you can see there's a sleeping bag here, which is very comfortable. The sleeping bag is fixed to the wall so that I don't float away or kick anything. And it's really comfortable to fly and float and sleep in zero gravity.
You're sleeping in a box, and you wake up, and there's your computer right in your face. And your computer has this timeline, and it's like yelling at you, get up and get to work. That's your daily life. You get up, we have time in the morning, you get up and get ready for work like you do here.
Doing your morning routine, washing a little bit, having breakfast, same as here on Earth. Usually crew gets up between 6 and 6:30 in the morning.
For meals, the astronauts usually eat dehydrated products to facilitate transportation and reduce the amount of space required for storing food.
So now our coffee packet is filled with nice hot water. We just need a little plastic straw. Insert the straw, take the cap off, and drink.
The first thing to do, once you've woken up and had your coffee, is to check the station parameters and report to ground control to say how you are and how things are operating. Then you receive instructions from ground control that might change the timetable a little. We usually plan things week by week.
To ensure the space station functions correctly, an efficient communication system is essential between the station and the Earth. In Houston, at the HQ of the American Space Agency, the teams are in contact with the astronauts almost constantly. From the control center, the engineers use telemetry to interact with many of the station's operational structures.
If you want to do anything, if you want to send a command, turn a pump on, turn a fan on, you have to go to a computer and pull up various displays and then send a command to turn that fan on. So for the crew, it's kind of a pain, but for us, it's what we're trained on. So the ISS is definitely flown from the ground from various control centers all around the world. We have a bunch of different team members all in charge of various systems, and that's only out of Houston. So we also have people in Russia, we have people in Germany, we have people in Japan. So again, we have people all around the world working, again, for sort of a common goal. But
a little better edge would be helpful. If you could tweak the holder or the sample, bump it a little bit, that would be helpful. Will do.
Each of the station's modules has ways of communicating with Earth.
Okay, this is our, it's called a PCS, which is basically information on how the station systems are doing. But most important thing for us are the comm, what is available comm-wise. And we have 4 different channels, space to ground 1, 2, 3, and 4. As you can see, it's upside down, but that's just the way it happens to be here for us. We need to talk to the ground quite a bit. They help us out tremendously. They're the ones with all the real knowledge, again, so we're just a glorified technician.
Ground control maintains voice commanding and also electronic commanding of the space station, primarily by using satellites which are in a higher orbit.
The International Space Station is constantly sending and receiving data via its satellite dishes. 36,000 kilometers above it, geostationary satellites receive the information and transmit it instantaneously to the ground. Communication is thus ensured all around the world.
Now we are in communication virtually 100% of the time that we're on board. But that wasn't the case 15 years ago. We'd communicate in little periods, like 20 minutes, when we communicated with ground control, depending on the orbit. Today we have good quality communication for professional use and for talking to family and friends. It makes for much better living.
Thanks to this communication, the astronauts are now able to share their feelings with the rest of the world. On Earth, human beings need oxygen, but in space, there isn't any. The International Space Station has several systems to produce oxygen and supply it to the crew.
The atmosphere on board the ISS is very similar to the atmosphere we have here on Earth. The only difference is we have quite a bit more CO2 on board the station. That's a real concern for the astronauts. So a big part of my job is oxygen generation. We have what we call an OGA, the Oxygen Generation Assembly. So it takes water, it's H2O, and uses electrolysis to split the hydrogen away from the oxygen.
Part of the oxygen is made in the Russian service module.
Here we are in the service module. It's not very big, but it's essential. This module contains all the systems needed for the cosmonauts to stay alive.
It contains reservoirs of recycled water through which electricity passes. This electrical charge isolates the chemical components of the water, hydrogen and oxygen. It's called an electrolyzer.
We can take that oxygen from the H2O and release it back into the atmosphere for the crew to breathe.
The oxygen is pumped through pipes that cross the station to provide the crew with fresh air.
So yeah, we can look at the constituents of the atmosphere and see how much oxygen do we have, how much CO2 do we need to generate more oxygen? Should we be scrubbing CO2? Do we need to replace nitrogen? Are we leaking overboard? We have a lot of different data, what we call telemetry, that we're getting from this room.
Making oxygen is one thing, but the air cannot stagnate. So the space station has a network of top-flight ventilators.
And so if you don't have any ventilation systems or any fans mixing the air, essentially you would get pockets of oxygen and pockets of CO2. And in the worst case, for example, if you were sleeping and you didn't circulate the air, you could in theory generate a bubble of CO2 gas around your mouth and suffocate on it.
Water is essential on the space station to drink, to wash, and also to breathe. In the early 2000s, when the first crew moved in, water was delivered from Earth in pouches. Today, the supply cargoes still bring water, but not enough for all the oxygen production or water consumption of the astronauts. So more than elsewhere, water is absolutely crucial and must never be wasted. To compensate for the absence of gravity, the astronauts must do a minimum of 2 hours of exercise every day, so they lose a lot of water.
When we do sports, for example, we sweat. When we wash ourselves, we use water and we dry ourselves with towels. These towels you just hang up in the air like you would do at home, and naturally they will dry up.
And we leave those towels close to a ventilation grid, like in this case you can see a ventilation grid right here, so that they can dry off. And all the water then is recuperated. It evaporates in the air, and then in the air conditioning system it condensates again, and it goes into our water recuperation bus, and it actually gets turned into potable water again.
Saving resources is a constant concern, and even the laboratories help.
So urine gets recycled through a process that actually turns it back into potable water. So we drink our pee.
And it separates the water and the air inside there, the urine in the air. And the urine, of course, goes to the urine processor. The air gets a little bit filtered and sent back out again.
And today we have managed to recycle about 70% of all the water that is on board of the ISS.
Today, this complex water recuperation and oxygen production system guarantees a supply of water and air that is often even purer than we have at home. And managing waste recycling is also key for preparing for longer voyages.
We can take the CO2, we can take the hydrogen from the electrolysis, react that with the water to produce more water and more oxygen, and then as a byproduct we get methane. In the case of the space station, methane is a waste product, and so we vent the methane overboard. But it's a very interesting reaction because you could potentially use this very same reaction on Mars to generate rocket fuel for your return journey home.
I'm going to take you to one of the coolest places on the space station.
The place that everyone loves on the International Space Station is at the end of the Tranquility Module, the Cupola. This dome, with 7 reinforced panoramic windows, always points towards the Earth, which is constantly passing. Traveling at a speed of 28,000 kilometers an hour, the International Space Station travels around the Earth 16 times a day. Its trajectory covers 85% of the surface of the globe and offers a prime observation post for scientific discovery. Within the framework of one of his experiments, Danish astronaut Andreas Mortensen is looking to film meteorological phenomena that are impossible to observe from the Earth.
And one evening after dinner, I was sitting in Cupola, and a gigantic thunderstorm started to develop. And so I took my camera and I started filming as much as I could. And it turned out that I was able to not only film some red sprites, but also a pulsating blue jet. So this cone of blue lightning that shot up from the top of thunder clouds. And that's something very new. It's the first time it's been captured on video like this. So potentially it could affect our understanding of climate change and global warming, because it's a mechanism whereby we can transport gases like water vapor from the troposphere into the stratosphere.
The cupola is also where the astronauts come when they have some free time.
I'm gonna miss that cupola, because I'd go in it every night for an orbit, and I would watch the Earth, and I knew that that was borrowed time. I wasn't gonna see that forever.
It's a haunting spectacle. You could watch the Earth for hours from the window because it changes all the time.
You tend to look big picture, and the longer you're up there, you start to narrow it down, and you start to pick out small bits of detail and start to identify places you might have visited or other things you want to look at.
When we go to other planets in our solar system, I think the moment when we can no longer see Earth through the window will be very stressful. Because for us on board the station, as soon as we have some free time, we always look back at the Earth.
In space, when they look at the Earth, the astronauts experience a unique feeling called the overview effect. It's an awareness of the place of Earth in space.
And your perspective changes with regard to this planet, which is so normal to us, so finite when you look at it from the ground.
The Earth is a unique organism. You can't see the frontiers of countries, but you can see the frontiers of misery. From up there, you can see the environmental catastrophes, the fires. And sometimes you get the feeling that the Earth is calling out to us for help.
It was like being in a movie where they might dolly a camera back, but zoom the lens in to where the actor, or in this case the Earth, doesn't change size, but your sense of reality around it just comes crashing down. And I had literally a physical reaction at that moment where you just kind of know, like, I get it. I just kind of get it in a way that I've never done before.
The journey to the International Space Station is a dangerous adventure. This trip to space starts in the heart of Russia, at the Baikonur Cosmodrome. It's here because, currently, the only way to send astronauts to the ISS is on a Russian Soyuz vessel nicknamed the Space Taxi. The trip to the ISS takes 48 hours. The astronauts are seated in this little module perched at a height of more than 40 meters high. Strapped into their seats ready for takeoff, it's thanks to this cabin called the descent module that the astronauts can also return to Earth. When the vessel arrives in orbit, the team can move into the orbital module. The size of a small truck, this is where they can relax. At the other end is the service module, which contains guidance systems, batteries, and motors for maneuvering. The team has to check the vessel's trajectory regularly and make adjustments if necessary. The trip takes them roughly 30 times around the Earth, the time it takes for the Soyuz to get into the same orbit as the ISS in order to dock with it. As it approaches the International Space Station, Soyuz turns to face the right way and slows down. Although it is automated, this approach is always tricky. If there's the slightest doubt or technical failure, the commanding officer must be able to take over to control the final approach. And it was during his first flight that British astronaut Tom Peake had to deal with an incident that could have had some dramatic consequences.
Everything was going fine up until about 17 meters away from the space station. So that was fairly close. In fact, that's the closest abort that there's been. And then we had a sensor fail with one of our thrusters. Yuri then had to take over manual control and complete a manual docking.
It was just a question of docking. The safety of the station depended on it. The ISS isn't a uniform structure. It's made up of many parts that stick out.
A collision would have been fatal, not just for the crew on the Soyuz, but for those on board as well.
Piloting in space is much more complex than piloting on Earth because there are 6 elements to manage. On Earth, when you drive a car, you have 2 elements: steering right or left, and braking or accelerating. Up there in space, you are managing 6 different variables at the same time. You can go left, right, up, down, you can pivot, anything you like. It's an extremely complicated process.
Transition to manual.
A manual docking is certainly a difficult task to do. It was made more complicated in our case because we were going from daytime to nighttime, and the low sun angle was reflecting bright light off the space station. So Yuri was having a very hard time seeing through the periscope in order to see the docking port and to get the spacecraft correctly aligned.
It was very complicated, but in the end, I managed to get a distance from where I could see the docking area, control the speed, and get the angle right. Eventually, we managed to dock it successfully.
Contact confirmed. And
Until those perilous maneuvers, the space station had never witnessed an accident. For some time now, private companies along with NASA have been developing new spacecraft to take astronauts to the International Space Station. The space workers are installing new docking modules.
One of the big steps, of course, was the removal of a large thermal cover by Rubens and Williams to expose the actual docking port to which the SpaceX Crew Dragon and
The station currently has 8 docking ports. In addition to the passenger craft, there is another kind of vessel that docks with the space station: supply vehicles.
We have a lot of unmanned resupply vehicles that get sent up to the space station. We have Japanese resupply vehicles, we have Russian, we have American.
Every 3 months, these vehicles supply the space station, delivering water, a few fresh products, clothes, tools, and experiments. Once emptied, these supply vehicles have another key function. They are used as the space station's trash can.
Space station is a closed system. Everything that you bring up at some time needs to come down. So if you bring up clothing, for example, for the crew, we don't have a washing machine, so the crew has to wear the same pants. You get 2 pants for 6 months. You have to wear the same t-shirt for a week or for 2 weeks. And then when it's finally dirty and it's trashed, all this trash is accumulated in the cargo vehicles.
Come join me in the Progress vehicle, which is loaded and ready to leave. It's filled with bags of rubbish. I need to crouch right down because there's not much room. I'll try and show you. Everything is arranged symmetrically to balance out the vessel. Heavy things go opposite heavy things. You can see here, for example, there are purification columns, buckets that we've used, and even our dirty laundry, and little packages with our trash.
The vessels filled with trash are then unmoored. They burn and disintegrate when they enter the Earth's atmosphere. But some of the supply vessels fulfill a last function that directly involves the ISS. They are used as motors because the station is unable to maintain the right orbit on its own.
The idea is the ISS is about 220 to 250 miles above the surface of Earth. So you might think, well, so there's no air, so why would you ever need to speed up? It should just forever be in orbit. Well, where the ISS is, there's actually a very thin amount of atmosphere there. It's borderline negligible, but it is still there. So we have basically this giant football field. I mean, the vehicle has a football field flying through space. It's getting a lot of air. There's a lot of surface area that's getting hit by the small amount of air that's in the atmosphere. So that does slow the ISS down.
And so the ISS altitude is decaying by about 2 kilometers per month. And if it were to have no reboosts, then eventually the space station would re-enter Earth's atmosphere.
Every 6 months, a supply vessel is used to readjust the orbit of the ISS. The vessel starts its motors and emits bursts of power to get the station moving to the right altitude. The thrust can be felt inside the station itself.
Now, the way I'm going to demonstrate the acceleration that comes during the reboost is by using this camera. 800 millimeter lens, so it's pretty massive actually, and there's no accelerations, virtually no accelerations on us. And you can see I'm floating this camera right here, and it's not going anywhere. And I'm holding it, I'm actually feeling the acceleration. I'm going to let go again, and here it goes, it's going to take off. I'll try not to let it hit you.
But it's not only the height of the orbit that needs to be regulated. They also have to keep the space station angled the right way.
So the space station maintains what we call LVLH, local vertical, local horizon. And that means that the space station flies around the Earth, always Earth-facing.
The station's steering system is based on 4 gyroscopes. Without them, traveling at 28,000 kilometers an hour, the ISS would turn endlessly on itself, and life inside would be simply impossible.
In zero gravity, if you knock it, it's going to tumble, it's going to move around like any object up here does. However, if I get this spinning, so once the gyroscope is spinning, you can just see how stable it becomes. And however I knock it, it's not going to change its plane. It's going to remain in the same plane.
The gyroscopes turn like a spinning top or bicycle wheel to ensure stability. But the rotation axis of the gyroscopes is also controlled, allowing the station to tilt to follow the curve of the Earth.
By maintaining this LVLH, it means that we have a great Earth observation platform. That's why our cupola window is always looking at planet Earth.
Play nice.
When they aren't carrying out scientific experiments, the astronauts are busy maintaining the station.
We do have one of the most important pieces of equipment on the International Space Station. Hidden up here, this is the vacuum cleaner.
Although a filter system ensures the elimination of particles and certain microbes, regular cleaning in this confined environment prevents bacteria from growing. It also allows them to find parts they thought were lost forever. There is always work being carried out on the International Space Station. The daily lives of astronauts include plenty of time taken up with repairs and improvement work. But despite all their precautions, there are sometimes breakdowns and even major damage. That's what American astronaut Tracy Dyson discovered one evening in July 2010, just before going to bed.
Everybody else had gone to bed, and I was doing my routine checks of the space station on the US segment. I was turning off the treadmill when all of a sudden red and yellow bells and whistles start going off, and it was way more than just our treadmill having a problem. And then it became pretty clear that there was a problem with the thermal control system.
The thermal control system is vital for the astronaut's survival because outside the station, the temperature varies between minus 150 degrees in the shade and plus 120 degrees facing the sun. On board the space station, the electrical apparatus, and in particular the computers, generate a large amount of heat. To get rid of this heat, the ISS has a cooling system. Cold fluids flow around the entire station. There are water-cooled circuits on the American segment. The central beam and the solar panels are cooled using ammonia, and the Russian segment uses a combination of chemicals.
We knew that the most critical thing that could happen at that point was if we lost our other pump module. If we did, then we would have to start considering whether to go home.
On the ground, as in the station, the crew realized that the situation was critical. To replace the defective ammonia pump, they would have to go outside the station and repair it from the exterior. More dangerous than any other activity, spacewalks leave no room for improvisation and require lengthy preparations.
All the days leading up to it are filled with activities that have pretty severe consequences if you don't do them right.
If a cosmonaut tells you they aren't afraid on a spacewalk, or that they did a flight to the ISS and were calm and had no fears, then they're lying.
There are 2 depressurization airlocks for spacewalks, one on the Russian part and the other on the American section.
Inside the space station, it's got the volume of, say, a 5,000 square foot house. So it's a huge volume, but that's a fraction compared to the outside structure.
Humans are incapable of surviving in the space vacuum. There is no oxygen. The body is exposed to extreme temperatures, to micrometeorites and cosmic rays. Carry out the repairs the astronauts therefore have to wear some extremely high-tech gear.
The spacesuit is a phenomenal piece of technology and engineering. It's a mini space station. It has to keep you alive.
The astronaut survival has a price because these spacesuits cost $15 million apiece. They are composed of a bubble helmet covered in filters to protect their eyes from the sun's rays, which could blind them instantaneously. Powerful lamps are there to illuminate in the dark, and a camera sends images to the ground. A small tube right by the mouth delivers water to the astronaut during their walk. Earpieces and microphones allow them to communicate with ground control and the rest of the team on the ISS. On the front of the suit, dials control the oxygen feed and temperature. Beneath the spacesuit, the astronaut wears a piece of clothing crisscrossed with plastic tubes through which cold water flows to regulate the temperature. A backpack contains reserves of oxygen and water, along with batteries providing total autonomy for up to 8 hours. Because of the absence of gravity, the astronaut cannot feel the weight of these 130 kilograms of equipment. But being able to move around with such a suit on requires exceptional physical capacities.
90% of what you're doing outside, you're doing with your arms and hands. And because it's a pressure suit, even moving your fingers in the gloves takes effort to open your hands, takes effort to close your hands because of the pressure and the stiffness of the gloves.
Such a task requires constant focus, and here, more than anywhere, there is no room for error.
It's one of the hardest, if not the hardest things that we do in space. It's not just physically difficult, it's also mentally difficult, because you are not only fighting against the pressure of the suit with every motion that you make, but you are concentrating the entire time. And the spacewalk itself is anywhere between 6.5 to sometimes 8 hours long, without a break. You're inside this spacesuit.
Assembling and maintaining the station required more than 1,000 hours of spacewalks. During these sorties, the astronauts carried out numerous essential tasks for the station. Without these spacewalks, the ISS wouldn't exist. At 400 kilometers above the Earth and outside the station, Tracy Dyson and Doug Wheelock hurried to remove the defective pump and replace it with one of the 4 replacement pumps on board the ISS.
Bigger than a refrigerator. It's very, very large box, very massive, and it. Thankfully, we had the use of the robotic arm. Doug Wheelock was on the robotic arm, hanging on to it, and then I translated and met him in the spots where we were taking it from and putting it in and helping to guide it.
4 spacewalks of 29 hours in total were necessary for these extreme plumbers to successfully repair the heating system.
The ground teams regained the cooling, and we powered up the space station, and we saved the space station. How about that?
Other than technical failings, the International Space Station and its inhabitants face other dangers. Richard Garriott is one of the non-professional astronauts who was allowed to travel to the ISS. He remembers the many alarms that would sound every day.
Because a small problem can quickly become a big problem, it's important that there are alarms for the problem when they're small to make sure you can address it before it becomes a big problem.
On board the space station, the biggest danger is fire. During training, the astronauts learn to become real firefighters.
You have a fire at your house here, you run outside, you call for the fire department, they can come, they can help you out, and you can leave your house, right? You can be safe. But on board the ISS, there's nowhere to go, so you have to fight it. I mean, you have to be able to put it out.
Another worry for the astronauts is that on board the station, they are no longer protected by the Earth's atmosphere, and the cosmic eruptions from stars can cause cancer and lead to genetic mutations.
The only thing that can really protect you against that is density of material. There's no amount of Kevlar or other impact protection that you can do to protect yourself from an atomic nucleus. It's too small, passes right through it. The best protection is to sleep or to spend as much time as you can behind as thick or heavy a mass of something you can. So for example, in the Russian segment where all the batteries are stored, those batteries are a pretty good protection.
In the case of powerful cosmic eruptions, the Zvezda and the Destiny modules are the best places to protect the crew. The third biggest threat to the International Space Station is space debris.
If you look through a 10 or 20-year-old window, there were impact spots of debris. It was obviously created by something incredibly small, like a flake of paint, but still was hitting at a velocity of up to 34,000 miles an hour, and so still makes quite a wallop.
An object as small as a grain of sand launched at 28,000 kilometers per hour could make a hole in the hull of the station, cause it to depressurize, and kill the crew on board. The engineers have drawn up a map that shows the parts of the space station most exposed to space debris in red. This allows them to identify the zones that need protection as a priority. The modules are covered with a layer of aluminum which slows down microdebris. A layer of ceramic and Kevlar reduces the debris to dust. The last layer blocks the particles and protects the astronauts. There are more than 100,000 pieces of rocket and satellites, the leftovers of human activity in space, in the path of the ISS, from the size of an apple to the size of a bus. The engineers at ground control are able to survey this debris and readjust the altitude of the station to avoid any impact. If any debris or micrometeorite shower are missed by their surveillance radars, the astronauts must close all the airlocks and go immediately to their Soyuz, where they must wait, hoping the ISS avoids the debris. If the impact is too violent, the Soyuz and the crew will return to Earth.
You kind of fall back on your training, right? I think everyone has been trained on debris avoidance maneuvers and close call encounters. You know, what we're doing here isn't fun, whatever, kind of have a good time with space. It's very real, and astronauts are not just tools, but people and friends, people that we train and talk to and our coworkers. So something we take very seriously here.
Since 1998, the International Space Station has been serving mankind, and it's thanks to the ISS that we have learned how to live in space. Today, everyone is looking to Mars and even beyond. Thanks to the ISS, these dreams may now become a reality.
I agree with Konstantin Tsiolkovsky. He said that the Earth is our cradle, and that it's impossible to stay there for all eternity. And I also think that humanity is obliged to become an interplanetary civilization.
Originally, the station was due to be removed from orbit and destroyed in 2020. But its life has been extended to 2024 or even 2028. Enough to maintain mankind's continued presence in space for a few more years to continue deepening our knowledge.
The research we're doing on board the space station right now is already helping for those missions. We're learning how to live and work in space. We're learning how the human body adapts. We're actually practicing human-robotic interfaces. We have astronauts that are driving rovers around here on Earth. From the space station, we're understanding those communication control techniques. We're growing our own food on board the space station. We're understanding more about radiation and how it affects the human body and how we can protect crews against radiation when we do these missions. So there's a whole plethora of research that's going on board the space station at the moment that is going to help us in those future Martian missions.
The International Space Station is already humankind's biggest technological success. But beyond that, it is proof that cooperation between people is possible.
I hope that human spaceflight at least can help people also around the Earth, bring them together and find peaceful solutions like we do in the International Space Station. Despite of the conflicts between the US, Russia, Europe and so on, a lot of tensions, we still work together, we still can operate together, we still do science together, we still work for the benefit of humankind together. And I would hope that people around the world would take example to the ISS for that.